Hello and welcome to IGCSE Mathematics 0580 Extended Course, Syllabus Topic E1 number, Module 1.2, which is about sets, Part 6, and in this video we'll be solving exercise 3 of chapter number 8. As we know, we are using Complete Mathematics for Cambridge IGCSE Extended Course written by David Rayner. Right, so let's start exercise 3 of chapter number 8. In question number 1, you have to shade the following sets. So in part A, it says A intersection B, and of course, to shade the region, they have given us a diagram, which is a typical Venn diagram having two sets A and B in terms of circles. And in order to shade A intersection B, we just have to look at this area because this is the common or intersection of set A and B, or the overlapping area of A and B. So you just need to shade that area. Right, so here you go. We have shaded that area which is the intersection of A and B. Right, so in B part, we need to shade A union B. As we know from previous discussion, union means you have to combine the elements of set A and B. It means that you just need to shade this region, and this region. In fact, all of these two circles. In part C, as you can see, it says A complement, and we already know that A complement means universal set minus A. It means that this rectangle, whole rectangle, represent the universal set, and you subtract this circle A, only this circle A, from all of these rectangles. So you only left with this area, and outside that of A and B. So as you can see, this is the shaded region or the required region for the A complement, where you have taken this circle, all of this A, out of this whole rectangle, which is the universal set. In part D, it says A complement intersection B. Right, so this is the A complement which we just solved in the previous part C. This is the A complement, right? And we're looking for the A complement and intersection of with the B, and this is the B, right guys? So this is B, this is shaded area, this is B, and this is A complement, and we're looking for the intersection, means that the common shaded area between these two diagrams, which is clearly, this is the only portion which is common between this shaded and this shaded, because this common, which is the intersection B, is in there, but it is not in there in A complement. So the only common left is this one, which is A complement intersection B. Now in E part, it says B complement intersection A. So once again, first of all, B complement, as you can see, this all shaded area is B complement intersection A. This circle purely is A. So if you look at the common shaded area between these two rectangles, which is this one, of course this one is common in here, and this is here as well. So only this part is B complement intersection A. In part F, it says B union A whole complement. So first of all, B union A. So if you shade B union A, so of course it is these three portions combined of A set and B set, and this is the complement. I mean, this is the universal. If it, I will take the complement later on. This is the universal, all of it shaded area. So this is all universal. So B union A complement means you have to subtract B union A from all of the universal set. So if you take this area out of this area, so you left this area. So this is B union A complement. Question number 2A part. In this part, we are given same like a Venn diagram. We have two sets A and B. The only difference is that B set lies inside of B, means that all the elements of B are inside of A, right? So in A part, it says the shade A intersection B set in this diagram. So first of all, if you shade only the set A, so this is the A set A. I mean, of course, you have to shade B as well, because B is inside A, so means that the elements or A is in B as well. So in the same way, B is only B. So if you take the intersection of these two sets, I mean the common of the shaded region between this A and the B, it will be only B, because this is the common in both of these diagrams. Now in B part, we are given A union B. Means A is this region and you are taking the union between these two, right? So union means you have to combine the shaded area of these two diagrams A and then B. If you combine these two, it becomes all of this region. So this is A union B. In part C, as you can see, it says B complement intersection A. So once again, first of all, B complement, so it means that you have to uh, basically, if you look closely, B complement is uh, universal set minus B. So you just take out all the element of B and the rest is the shaded region. So this is the B complement, and A is only A, all of this area. And if we take the intersection of these two shaded area, so this is what we left with, right? What we said, intersection means common of these two diagram, common shaded region of these two diagram is this one. So this is the B complement intersection A. In part D, it says B union A and then complement. As we already know, complement means that we have to subtract B union A from the universal set, means an universal set E minus B union A. Let's do it step by step. Universal set, if you shade all the universal set, it is like that, and you have to subtract minus B union A, that is this is shaded area, this is B union A, so it is all like A and B shaded, so this is B union A. Now in that case you have to subtract this universal set minus B union A, and this is the area you left with. You can imagine very easily that if you subtract this to this, you will left with this, and this is B union A complement. Right. So in question number 3, it says A union B. Now we are given once again a Venn diagram, and this is a universal set here. Here is a universal set. We have two separate A and B. So you can see that this there is nothing common in between A. There are two discrete sets A and B. So once again we have to shade that A union B here. So A is this one, this is the shaded part of A, and B is this one, this is the shaded part of B. So A union B means we have to combine these two shaded part to become this picture. So this one is A union and B. In part B, it is given A intersection B. So once again, A is this shaded region, B is this shaded region. For intersection, we need to see something common of these two shaded region. As you can see that there is nothing common between these two diagrams, the shaded region. So it is an empty set like this one. This is A intersection B. Right, so in C part it says B complement intersection A. So once again, B complement is as we know that B complement is universal set minus B. So we have to take the elements of B out of this all of this universal. So we are left with this all this area. This is all shaded, and this is A. Now we are looking for the intersection. Mean we are looking for the common shaded region between this drawing and this drawing, and clearly this is the common between these two, and this is B complement intersection A. Right, so in D part it says B union A complement. As we know that complement means you have to subtract the elements of B union A from the universal sets, mean universal set minus B union A. So first of all, universal set, so you have to shade all these the rectangle because this is all universal set, minus A union B, this is the A union B. So now you have to subtract these two shaded area from all of these. So of course we will left with this shaded area, and this is B union A complement. Right, so in question number 4, we are doing some selected part because part A, B, C, D, E, F are very easy. I mean, a little bit concentration, you will be able to solve it. Let's look at that part G. It says A intersection and then bracket start B union C complement, and we are given a Venn diagram. In this case we have three sets, and you can see they're quite a lot intermingled, they're quite a lot common area, they're overlapping with each other, all these three sets A, B and C. So first of all, same method, let's say shade the set A. So this is set A, all of this, right? And then B union C complement, it means that you have to remove the elements of B and C, and the remaining is our desired area, because B union C complement is universal set minus B union C. So we have minus B union C from the universal set, and we were left with this shaded area. Now we're looking for the common shaded area between A and B union C complement, and you can see the common area is only this one, as you can see here. So this is A intersection B union C complement. Okay, in part J it says A union C and then union of B complement. As A union C is in brackets, so we will be solving it out. So A union C, let's shade out A union C. As you can see, this is the shaded region of all these two circles representing A and C. So it is A union C. And then B complement, as we know by, after doing so many questions, you should be fluent that B complement, you just have to remove the elements of B from the universal set. So this is all B complement. Now union means that you just need to combine these two shaded region. It means that the only missing portion is this 3 1, and you're getting this from 3 from this A union C, and this portion is still empty. It means that even combining these two, this portion will remain empty and everything will be shaded. So it is A union C union B complement. Right. So in the K part it says A union C intersection of B intersection C. So first of all we will shade A union C. So we just need to shade A and C together. For B intersection C, we only shade the intersecting area or the common area between B circle and the C circle. So these two parts are B intersection C. Now we will take intersection of these two shaded regions. So you can see that the common shaded region between these two drawing is only these two portions, this one and this one. So this is A union C intersection of B intersection C. Question number 5 is pretty much same as question number 4. So in the next video we'll be solving question number 6 and 7. So see you there.